Hey, this is Adam Lester, and this is our senior design project for Blackout safety device. My team partners for this project are Tong, Antonios, and Yasim. What is an underwater blackout? An underwater blackout is the loss of consciousness caused by the cerebral hypoxia towards the end of a breath hold. Cerebral hypoxia is when the brain is completely deprived of oxygen. What are the two common causes of an underwater blackout? The first is hyperventilating before a dive, causing low CO2 levels. CO2 levels normally tell the body when it needs to breathe. With low CO2 levels, your body won't use the oxygen in your lungs when you're holding your breath underwater, causing the underwater blackout. The second thing that can cause an underwater blackout to occur is coming up near the surface from an underwater dive and your lungs decompress, suddenly causing a lower blood oxygen level and causing the blackout. Currently, the best method preventing an underwater blackout is the buddy system. When diving, your buddy is supposed to always watch your back for unexpected dangers such as blackouts. The problem is, the buddy system does not work all the time. Every year, people die from underwater blackouts, many with dive buddies who were not aware of the danger until it was too late. On average, blackouts take 2 minutes to kill. An example of this would be two people are diving, and one goes up to the boat for a brief time or just isn't looking in the direction of their dive buddy, and 2 minutes passes and they die. Here we have a chart showing the fatalities of blackouts in the United States for the years of 2004 to 2014. So this is where our device comes in. The blackout safety device is a product that will monitor a person's health and prevent underwater blackouts and ultimately underwater blackout deaths. It could be used for free diving, scuba diving, and regular swimming. As the project progresses, this device can also be used for skydivers and mountain hikers. The most important features of this project are, first, to potentially save lives, adjustable wristband, it's rechargeable, and waterproof. And here we have a picture of our device. The device currently isn't waterproof yet, but it will be in the final product. This is the block diagram for our project. The data in comes from the person, so we take the blood oxygen level and the heart rate. This is taken by the pulse oximeter. Then we convert it from analog to digital. Then it has two options. It could be a dangerous condition, so like the blood oxygen level is too low, and it will vibrate and have an LED, and then it will be displayed on the LCD screen. Or it will be a non-dangerous condition, and it will be displayed on the LCD screen. This is the circuit design for our project. Inside the watch we have a battery connected to an Adafruit battery charger, which is connected to the Adafruit M0 ITSB containing an ATS SAM D21 Cortex M0 processor. The processor is about 4 times faster and has more memory than the AT Mega 328P. Also connected to this, we have the oximeter sensor, LCD display, LED, and the real-time clock. How does it work? The watch detects an occurring blackout and then notifies the diver and his or her dive buddies. The pulse oximeter will detect the person's blood oxygen level. When it falls into dangerous levels, it will buzz notifying the diver of his low levels, and it will emit an LED to notify his dive buddy. Here is our current watch. We've got the screen, the charging port, the hole for the sensor, and the hole for the LED. The device does have a battery inside, and here's a video of it not plugged in. This is our first test of the blood oxygen level of a finger. When it shows 0, it's an error, and the watch will bypass that. We can also see the heart rate, time, and date. This is our second test on the wrist. Again, we can see the blood oxygen level. Many times it's in the hundreds or upper 90s. There tends to be more 0 values on the wrist, so it seems to be more inconsistent than the finger test. This is the third test, is taken on top of the wrist. The numbers seem to be more consistent than the bottom of the wrist. This is our division of work. Adam, myself, led the project, did research and part testing. Tong was responsible for software, 3D modeling, and testing. Antonios did 3D modeling and hardware, and Yasim performed the documents. This concludes our video. If you have any questions, you may ask them now.